Hey guys, TJ Schwartz here. I know I've been on a bit of a hiatus from YouTube, but I'm coming at you with a new build series. I want to kind of up my YouTube game. I really enjoy doing these. I got super busy. I feel like last year I've just been super focused on the shop. We've just changed so much, and especially on this new model that I want to do this build series on, so much is changing, and some of my old videos, which I think were cool, are now outdated. So I really want to get new YouTube content up, answer questions, and just show you what I'm all about. So right now it's a Saturday. Dalton, my employee, he's at home, and I'm just trying to focus on building a fixture on the sile for machining the tangs of this new model. Now let me show you this model. So I have right here a laser cut blank. Laser cutting is not something I've used on knives yet. I've used it for other things, but the local shop in Boise does a nice job, and I decided to give it a try. Normally I would have these water jet to this stage, but here is a laser cut blank of the new model, which is called the Lost Trail 5. That would be LT5 for short, 5 meaning 5-inch blade. Lost Trail is a name that means a lot to me. It's a geographical area near my hometown that I really enjoy. But this is a 5/32 thick piece of A2 tool steel. It is not magnet cut. I have a lot of reasons for this, and I'm excited to share that along down the way. A2 tool steel, LT5. These are laser cut and will be fully machined on the perimeter. I will not be leaving any laser kerf. But the point of building the fixture and trying this out today is actually I want to prove to myself whether or not this laser finish is going to work to then later be machined, because the laser actually hardens steel when it cuts it. And this is A2. A stands for air, meaning this is an air quenching steel. So if you heat this steel up to any temperature hot enough to cut it, and then it air cools, you have a hardened edge. How thick is it? I'm not sure. How hard will it be on my tooling? I don't know. That's what I want to find out. I've got like 20 of these that I had laser cut, and I need to build a fixture to see if I can machine it. If I can't, or if the wear is not great on the tooling, or if I have any issues, I can go back to water jet at a much greater cost. So I'm trying to see if the laser option would save me a few bucks, or if it's just a waste of time. So I've got this all programmed up. It's a Pearson pallet. It's going to have 4 of those Lost Trail 5s on there, one after the other. I have to machine some sort of plateaus, drill a bunch of holes, a bunch of 1/4-20 threaded holes for the hold downs and whatnot. So I'm going to go ahead and hit cycle start. I actually spent this morning getting the machine set up and ready to go. So the first thing it's going to do is go through and face the actual fixture. And I'm realizing I probably made a mistake. I touched my Z off at the top of the pallet, and I usually then offset my Z coordinate system down by about 5 thou so that it faces off 5 thou. I think I forgot to do that, so I don't think it's actually cutting. All right, let's try this again. I just updated the Z to be 5 thou lower. I always have my rapids turned way down when I'm doing fixtures. Fixtures are where I feel like I'm most likely to crash a machine, so I always start with a slow rapid. There we go, now I can hear it cutting. So it's just gonna go back and forth, nice and slow. I'm trying to put as good a finish as possible on there, and it's just decking 5 thou off at the top. While the sile is doing that facing operation, I just wanted to do a quick announcement. Up to now, all the knives we've been selling that you may have seen before, all the magnet cut stuff we've been doing, we've been configuring and custom building to order, so there's been a lead time on all those. That'll continue to exist. That's a huge part of what we do. But if you're watching this video, there's a good chance we've already launched a new page on our website, and that is in-stock knives. We are working on having in-stock knives as much as possible so that you can either configure with a lead time, or you can order and get it directly. And then later you can order additional scales or a different sheath. You can always continue to modify the thing, but we want to have like assembled knives on the shelf that you can just buy, just like a normal knife company would. So check out the website, schwartzknives.com, and see if there's anything there you like. Appreciate it. So the facing op just finished. You can see how nice and flat. This is just a piece of extruded aluminum when it comes from Pearson, so if you want something to sit on it, it has to be perfectly flat. So 3/8, 3 flute, end mill, did that step. Now I'm gonna go down to a 1/4 inch, and I'm gonna do a whole bunch of material removal with a 1/4 inch 3 flute. And the reason I had to use a 1/4 inch is the 3/8 is not gonna fit in between the plateaus that the knives will sit on. Now I changed a lot of my feeds and speeds techniques on this go around. I'm a little bit more aggressive. I'm curious to see how this is gonna go, but first it's just gonna do a little notch out of the corner, and that's just for future probing purposes. You can kind of see it just notched the corner out. Whenever I put this pallet back in the future, that's where I'll probe off of. You can use like an outside corner. I just don't like it because when you're putting them in and out, you can ding these, like putting them on a shelf or something. So if you have an internal corner to probe in the future, it's way less likely to just get damaged and lose accuracy. Next up, I'm going to drill some holes. Whenever I do that work offset corner like that, the very next op, I always have that be the location features on the pallet. So for example, I have 3/16 pins. This is pre-drilling for those to be bored. I want the locating feature to be probed, to be machined right at the same amount, at the same time as my locating features for the knives. I could do that notch, do all my other stuff, and then do these precision holes at the end of the operation, but that leaves time for the thermal change of the machine to give you a discrepancy between the location pins and the work offset. So this little 1/8 inch end mill, I know you can't see much, it's gonna drop in and interpolate these little tiny pinholes. All right, so I've got all my 3/16 pin holes for press fit pins located. They're all bored to precision diameter, and I have that work coordinate over there. So everything from here forward is for things like clearance, for bolt, like threaded bolt holes and things that aren't precision toleranced. They need to be obviously really close, but the location features for the part on the fixture and the work coordinate system are now perfectly aligned. So the next one, I misspoke earlier, this is the operation where I went a little bit more aggressive. I went full depth to machine a ton of material away, and I just want to see how this goes. It's an adaptive toolpath, so we're gonna find out. It's just a 1/4 inch end mill. I'd love to use the 3/8, but again, I don't have clearance. Let's see how this sounds. Again, full depth. It's not super deep, it's only like 200 thou deep, but I'm curious about my chip load and my, we have a problem. So the machine just aired out. I know exactly what happened, and I was actually worried about this. This Pearson pallet is located at the very front of my work envelope. I have a very small margin. I could push it further back, but it would also be getting pretty close to my tool setter back there. I might actually move this back, but right now I'm not too worried about that. What actually happened was this end mill is about to plunge down in here and start machining at 200 thou depth a whole bunch of material away to leave plateaus for the knives to sit on. And the lead-in for that operation was going to try to be right here based on the way it was programmed. And that lead-in was going to be outside of the actual work envelope of the machine. So I moved the lead-in back here where I have more room, and we're going to try it. But yeah, little error. Thought I'd share that with you. New program. Let's see if it'll go this time. Yep, it's going to the back. Let me see how aggressive this sounds. Oh, that sounds pretty good. Yeah, we're gonna be here a while. This is the longest part of this operation. It's just gonna go around and around and around and around, machining inward. It's a trochoidal milling tool path to close down in on those remaining plateaus that I want. All right, you can see the plateaus for the knives. You can see the nice floor finish. This turned out really good. I'm not going to talk too much about the design of the fixture. After I get this all built, I'm going to set it on the bench and talk about some of these features and what's going on here. But up next, I'm going to drill some holes, and then they're going to get 1/4 20 rigid tapped, which is always fun. a letter D drill size. That's .201 diameter is the pre-drill diameter for a 1/4 hole, at least the way I do it. All right, time for the rigid tap. This used to pucker me a lot. It still does a little bit, but this Sile is really good at rigid tapping. Knock on wood. No problem. I've now got the fixture off of the machine. The fixture is complete. Let's talk about it a little bit. Complete, except I still have to build some clamps. So for hold down, we have laser cut holes or water jet, depending on what we go with, that are sort of like a weight relief pocket in between the bolt holes. And we are bolting through those, and we also have location pins in those. So one location pin is on the top of the pocket, one is on the back of this other pocket, and then the third point of contact is, I have an end mill with a drill bushing on it. I'm gonna turn this into a real tool with like a 3D printed handle and probably JB weld this bushing, but I put these steel hardened bushings right here. So you'll have a hand tool with a big red handle on it that you slide in right here. And that drill bushing is what sets this gap. So if you have 2 points here and 1 point here and you squeeze these together with this precision bushing, then you have a perfectly located part, and bolt down through these holes and then put a clamp on right here, which I have yet to build. So you're holding the tip down, you're holding the handle down, and the benefit here is we can drill our 3 holes for the actual hardware of the knife, here, here, and here, and then go around the perimeter in one op without moving this, because I want my 3 holes to be perfectly in alignment with the perimeter shape. That's because we're not shadow boxing these. They're actually going to be flush with the handle. And so any situation where, like on our other knives, we drill 3 holes and then we mount it to a second station through those holes, which then allows us to go around the perimeter. But in that move, those 3 holes can be a little bit out of orientation to the perimeter. Now, the other knives have chamfers and shadow boxes, so like a 1 thou float in there is not a big deal at all. But in this knife, it would matter. I don't really want to chase that forever, so I'm trying to build a fixture that's more robust than that. I do have a few worries about this fixture. One of them is that if you look, I've got a bolt hole down here. There's a pretty big space where when the tool is machining the perimeter, where this is actually possibly going to cause chatter. And it's only 25 thou that's being machined off, and I can go pretty slow. So hopefully this isn't an issue. If it is, I'm going to have to add essentially like a strengthening clamp that these 2 bolt through, that adds strength out here to keep it from lifting and causing poor finish or poor tool life there. And then the other thing is I have a clamp here, so the machine will perimeter machine from about here all the way around to the tip, and it'll skip the little section of the belly where this clamp is sitting. Then it'll hit an M0, the machine will stop, and then the operator will pick this clamp up and then put a different clamp here. You can see there's 2 more bolt holes, allowing freedom to just machine that last little bit. Again, we have a little bit of a possibility of bad finishes because of not a great hold down right here on the tip. So in some ways this fixture is not ideal, and we are going to see if that's going to cause problems. But I wanted to start with what I thought was going to be the most efficient fixture and see what the results were from a tool life and finishing standpoint. And then if we have to add to it to improve those features, we can. These clamps, I could get some really wild shapes going on to help hold some of these areas. But I'm going to start simple, and if it's simple works, we'll stay with that. But the ideal goal here, like I said, is these parts never move. They go on, they're 100% machined, they go off. Now, the laser cut pockets, they will never be machined. They could be machined, but these are all going to be Cerakoted. It is A2 tool steel. It is not stainless. They will all be Cerakoted. And so the Cerakote we'll be using will cover the laser and won't look really much different than the perimeter. The perimeter will just have the huge benefit of the precision of a CNC mill, leaving a perfectly perpendicular flat surface for the scales to interface with. So yeah, that's the fixture. I'm really happy with it. I do need to build clamps. I'm not going to show too much of that. My technique for building clamps is I have steel and I'll just window it out with tabs, pop it out, and then I'll sand the tabs off, a couple through holes. So I've got steel here ready for it. I'm not going to really show that because it's like really basic machining 101 for just a rectangular clamp. But next time I jump on here, I'm going to have clamps ready. I might not get to them today. It is Saturday. Kind of promised myself I wouldn't take too long, but I do have this done. I'm so tempted to find a way to just real quick clamp these down in some way, but I'm going to hold off, be patient, and get the real clamps going. I really am curious how that laser kerf is going to machine. Can't wait to see that. Alright, so I've got my clamps made. I laser engraved them, hopefully help from making mistakes in the future. This is the second one I mentioned that goes right here. I do sink the middle down, and the reason for that, you can see the kind of shelf and plateaus there, is if you just put a flat piece of steel, all of the force is going to be right on the edge of the part. And I've seen where the part will actually rock. It wants to roll, because as soon as you start bolting these down, you get a little bit of flex, all the pressure goes on this inside edge, and you don't get any clamping force on the outside. So by having these plateaus, it puts the force in the middle of the part, and this one is the same way. So I've got this in here, I've got it all probed in. I'm gonna go ahead and hit cycle start, and it really is the moment of truth. Let's see what happens. So first things first, it's just drilling some holes. For now I'm interpolating my hardware bolt holes, and so it does a pre-drill with just a high-speed drill, and then after that it comes in with an end mill. Got the rapids turned down. I would like to go to a drilling and reaming cycle as opposed to this interpolation, but the interpolation does give me more control over the diameter if I need to change it. This is pre-drilling the lanyard hole. I need to clean this window for the next video. Interpolating that hole. And I'm going to cut it off. I'll jump to when it machines the perimeter, which is what we really care about. Alright, here we go. It's going to do the perimeter. I'm listening for chatter as it goes around that pommel area. We're going to see how this rolls. This is not a brand new tool. We've been running this one in production a little bit, so if this proves decent, I'm gonna throw a new tool in and see how that one sounds. It definitely sounds different than the MagnaCut because it's got that hard edge. Okay, the sound going around that pommel did not sound much different, which is great news. Although I don't love the sound I'm hearing. I think it's probably because the feeds and speeds are for soft MagnaCut, and I need the feeds and speeds to be for like a semi-hard tool steel. So it does the first pass with the end of the end mill, the very tip, and does the roughing, and then it drops down and uses the bottom portion of, or sorry, the higher portion of the end mill that's fresh, and does a finishing pass. So I get a rougher and a finisher out of one tool. That's part of why it sits on such a high plateau, the knife, is I have to be able to drop the end mill even further than what you normally would. So I did a little custom G-code. After this, it should go home, and it should park the table, and it's gonna allow us to move the clamp. But I did not put a G-code in to shut the coolant off, so I'm gonna have to do that.
So as you can see, it went all the way around the perimeter, leaving a beautiful finish. Feeds and seeds are probably not ideal for tool wear. I didn't love the sound, but the finish on that finishing pass is what I want. So if I change anything, it might just be the roughing pass. You can see how it comes out right there. So when I get rid of this clamp and put a clamp right here, it can do the tip. And there will always be a seam when you merge two machining operations like that, a tiny, tiny seam. But this is gonna get sharpened, so unless it's a pretty big step right there with the seam, it's never gonna be seen. But the nice thing is, like I said, the part's not moving. We're gonna leave these bolts still located even if I get rid of that clamp and put a new one on. So that seam should be marginal, if not barely visible. So I'm really happy with how that went. I did not get chatter out here, at least from what I can tell sitting here in the fixture. I did not hear any excessive resonation there. Yeah, I like this. So I'm gonna move the clamp and run the tip. All right, I moved the clamp over. You can see the exposed area that needs machined. Hopefully we don't get chatter out here. That's another possibility. I'm going to hit cycle start. In the program, we hit an M0, so we're still in the same program, but it's gonna stop and go home like this and allow the operator to make this changeover. And we have Z-axis negative software limit exceeded. Let me do some digging into that. All right, so I believe the reason it was wanting to exceed the Z-axis soft limit, which essentially means it thought I wanted the tool to go either up or below what's actually available for the machine envelope. Usually that means there's some sort of work coordinate anomaly, and in this case I think there was. I don't have a tool change happening between doing the perimeter, M0ing, going up, and then doing the tip. There is no tool change, meaning there's a block of code with every tool change that you need to have. And if you just M0 and you don't use this, and you then home the machine, like at the end of an operation, I know this is getting into the weeds, but essentially a section of that was missing. I did it manually and I thought I had it right. And I ended up using Fusion to just force a tool change. Even though this machine, it already has the correct tool, I forced it to tool change, so it goes up to the position, turns the coolant off, thinks about it for a second, it says, oh, I already have the right tool, then hits an M0, and the M0 stops the machine and awaits you to hit cycle start again, which allows you to move the clamp. So it took a little bit of fiddling to get that to work right. I think I got it though. So I'm back to getting ready to machine that belly. With all these changes, I have my fingers camped on the E-stop. Let's see how this sounds. Oh, that sounds really good. Oh, and I also put a fresh tool in, so I think the loud high-pitched sound from the last cut was actually the dull tool. Sweet. That is the first LT5 ever machined right there. Unless there's something I'm missing, that knife is ready for heat treat. Let's take a look at it. So I got the part out here. Looking at our finishes, I love it. I don't know how well that'll show up on camera, but that is as perfect as you can expect from really any CNC mill. This style is so good at finishes, and you can see on the pommel, hopefully that's in focus, not getting any chatter. So I will not have to over-engineer this fixture, I don't think. Like I said, I started as simple as possible for maximum efficiency, and it looks like it possibly is going to pay off this time. So that is a finished blade ready for heat treat. It's all oily and greasy, I know, but look for that seam. Basically non-existent. The precision of this machine, I've done operations like this before where I'm trying to hide a seam, and in this machine's ability to go hit that same spot again is downright unbelievable. It is really, really nice. So the first LT5 off, I've got 20 more. I'm gonna run them. I'm gonna be looking for indications of tool wear with that hardened edge, but we might be good with running with laser instead of water jet. I'm gonna run the 20 more. I'll give you another update, and we'll go from there. So I ran some more of these. I didn't run them all. I decided to kind of hold up and do some thinking on it. I did have a couple issues. These seams that I was describing just a second ago that were invisible were more visible on a couple of these, and I wasn't sure why. I wasn't sure if there was a tool deflection problem or a shatter. I wasn't sure, but they were small enough that they, I believe, would sharpen out easily and just fine. And then one of them totally shifted in the fixture, and I heard it shift, and the end mill just gouged right into it when it was doing that little tip section. Totally scrapped the part. And it occurred to me that what's happening with these is while that tip is being machined, the knives were moving just a tiny bit due to just tool pressure and not enough clamping force. So I increased the torque on the drill on both the handle bolt holes, handle area bolt holes, and these bolts, and that seemed to solve it. But then I did an extra measure of sandblasting the actual clamps, so I will have a lot more traction on the part. You can just feel the friction now, and I believe on the second clamp there's coolant that is obviously covering this, and the first clamp is on dry seal, but the second clamp is on a now coolant impregnated surface, and there wasn't enough friction. So I believe I've solved that. I believe this is going to work. Again, this fixture doesn't have as much hold down as you would conventionally want to achieve, but I'm sacrificing a bunch of hold down opportunities for a really tight tolerance situation. So much so that, like, my work offset, if thermally or due to a user error or whatever, if it were to move by, like, let's say 5 thou or even 10 thou in X and Y or Z, all the parts are still fine. Basically, my work offset is plus or minus 10 thou in all dimensions, and they're always going to come out perfect. That's what I wanted. I want this thing to be dead reliable. They're always going to be the right shape with the right hole locations no matter what. And I believe I've achieved that. So we'll see as production flows how that works, but I'm feeling good. I came to another conclusion though. The machining of the kerf, the hardened kerf on this, didn't seem to be an issue. Like, it sounds really good. It's resulting in a good finish. I don't think it's a problem. I was a bit worried about that, but there's some areas on some of these where they overheated. You can see right here, there's that brown, there was a big chunk of slag, and I actually ground that slag off in preparation to machine it. And I put this particular knife on a plate, on a surface plate, and right where it overheated, there's a little bit of a deflection. And that was one of my worst fears. If you're in the corner of the sheet when the laser's cutting and there's not enough steel around it for that heat to dissipate, which is where this one was, I watched the laser cut it, so I could see this happen right in the corner. Without heat dissipating, the heat is being sucked into the part, and you're going to get extra slag wherever you have an overheating situation, and you're going to get potential warpage. I saw a few of those in there with warpage. Out of the 21 parts, there's maybe like 5 or 6 that have at least noticeable warpage. It can be corrected, I believe, on these particular parts, but it has me very, very spooked about laser. This laser shop does a really, really good job. I've had them do a lot of work for me, but there are limitations to cutting a tool steel with something that is so hot that it is going to harden the steel. Beyond just the edge finish, there's situations like that occur. It's just the nature of the technology. I just know that the savings to laser, if they result in some warpage through the life of this product, I'm going to be losing money because of that. The water jet cost increase is going to pay for itself probably 10 times over if I don't end up with excessive warpage. I just hate warpage in the shop that much. So I'm going to make the call. I'm going to go to water jet. These are going to work, but that's what's going to happen. I just don't trust it. I have 7 more sheets that I want to have cut like all at once to get this project rolling, and each sheet cuts in 5 minutes on a laser. So in a total of like 40 minutes, I could warp, hundreds of parts, and that's terrifying to me. So we won't do that.
yeah, so water jet, fixture improvements, and I am feeling overall confident. I have data. That's what I was trying to do here. There's a reason I just cut one sheet, and the fixture seems to work. I think we're good. That's a wrap on part 1 of the LT5 build series. I wanted to add a quick note. I do have a CAD course available. If you are really interested in 3D modeling using Fusion 360 to do things like this, I have a CAD course specifically around designing and modeling fixed blades. The website is designincad.com, and there's a bunch of videos on there. Definitely check it out. And I appreciate you guys following the channel here. I really, really appreciate you guys buying knives for me. It's an awesome, awesome thing to have support from people like you. So keep tagging along. The next part of the build series will be coming up. These will come back from probably water jet, it's looking like at this point. And we'll be working on, well, they'll go off to heat treat and I'll start working on handle scales at that point. Can't wait.